Okay, upper and lower bounds. So, first thing we need to find is what have we rounded to? We rounded to the nearest 0.1 grams, which makes sense because 0.1 grams is the last bit that has information in it. We always have plus or minus a half of what we rounded to, and therefore we're going to be at plus or minus 0.05 grams. So our upper bound is 14.6, and we're going to add the 5, and notice that it's here on the second point, the second set of decimals, so the tenths, the hundredths, so we're going to put that there. And the lower bound. Okay, this time we're going to take it away, so we'll get 14.55. And those are our upper and lower bounds for question 1. Right then, question 2. A road is 37 kilometres to the nearest kilometre, and we're asked for upper and lower bounds. Okay, to the nearest kilometre, therefore we're going to have plus or minus 0.5 kilometres. So the upper bound is 37 plus half a kilometre, and the lower bound is 37 minus half, so it becomes 36.5 kilometres. Let me just draw a line along here so that it's clear where this question starts. Okay, and that is the second part done. Okay, question 3. Let's block that off. So, for question 3, we are told that we've got a distance 200.0 kilometres, and that should immediately make you be going, I wonder if we've rounded to that, to the 0.1 of a kilometre, and 3.5. And again, you should be going, I wonder if we've rounded to 0.1 of an hour. And what we find is they're both accurate to 1 decimal place. So that would actually be correct. We are going to have plus or minus half of that. But what's the question actually asking us? It wants us to find the upper and lower bounds for speed. So, speed, distance, time triangle. Or you could do it in other ways if you know other ways of doing it. Distance, time, speed. So speed equals distance over time. So, we've got a range of numbers that our distance could be, and a range of numbers that our time could be. Now, if we want speed to be maximum, what we're going to want is this number on top to be as big as possible, because the bigger the number you've got on top, the bigger the number you'll get overall. Try it out. Let's imagine we've got 4 and 2. 4 divided by 2 is 2. 6 divided by 2 is 3. As this number went up, speed went up. So, what that means is that if we want our speed upper, we're going to want to have our distance upper on top. Now let's look at time. Well, if we've got the number on the bottom, if we want the speed to be as big as possible, we're going to want this number to be as small as possible. Let's have a think about it. Let's do 12 divided by 4. 12 divided by 4 is 3. If we decrease t to 3, 12 divided by 3 is 4. So it's, if you want s to be big, you want t to be small. Therefore, we're going to want t lower bound. Okay, and that's how we're going to work out our speed, upper bound for speed. And in exactly the same way, we want to find our lower bound for speed. We're going to want to have our lower bound for distance over our upper bound for time. Okay, let's give ourselves a little bit more space, and we're not going to have space to do this on this side, so let's just mark that off. So we were correct to plus or minus 1 decimal place for distance, so therefore we're going to have plus or minus 0.05 kilometers, and we're going to have plus or minus 0.05 hours. Now remember, this is 3.5 hours, as in 3.5 hours, not 3 hours and 50 minutes. So we've got our range, which is always half of whatever we rounded to. So we can now calculate our distance upper and our distance lower. Our distance upper equals 200.0 plus 0.05, so 200.05, and our distance lower is 199.95. That gives us our upper and lower bounds for distance. In the same way, we can look at our time upper, and we can go 3.5 plus 0.05, so 3.55 hours, and our t lower is 3.5 minus 0.05, 3.45 hours. So we now need to find our speed upper and speed lower. So speed upper equals distance upper, 200.05 divided by t lower, 3.45, and that equals 57.9851. Alright, I would much rather round that to a more accurate number. Well, not more accurate, more realistic, and we'll deal with realism later on. So S up equals, I would round this probably to 1 decimal place as well. So this would be 58.0. Now what are my units? Kilometers and hours. Kilometers per hour. And that's the first one done. Now S lower equals the D lower, 199.95, divided by T upper, 3.55, and that equals 56.32394. So S lower equals 56.3 kilometers per hour. And that is how we deal with these speeds and densities and rate questions. Is we have to find the upper and lower bounds of the things that make them up, and then work out how they go together. For a divided one, you're going to want bigger on top and then smaller on bottom to get up, or smaller on top and bigger on bottom to get lower. Okay, let's move on to the next one. Right. Question 4. So we're asked for density. So very first thing, we need to work out how did density come into this, right? So we need to create a density mass volume triangle. Mass, density, volume. So density equals mass over volume. As before, D up equals M up over V min, and D min equals M min over V up. And sorry, earlier on I said lower, here I'm saying minimum. I do actually mean exactly the same thing. Let me just change my terminology so that it makes more sense. Lower, lower, lower. Okay, so we need to have a look and see, well, how are we actually measuring these things? Okay, so 1.25 kilograms to the nearest gram. How many grams are there in a kilogram? There are 1,000. So we have rounded here. Okay? So our kilograms are going to be plus or minus half a gram. Sorry, I mean our weight is going to be plus or minus half a gram. Okay? Which is going to be plus or minus 0.0005 kilograms. So mass upper equals 0.1255 and mass lower equals 0.1245. Moving on to volume, we have calculated the volume to 3 significant figures. Remember, significant figures, this is not a significant figure, so 1, 2, 3. So therefore, it's going to be plus or minus half of that third dot, or the thousandth. So we're going to be at plus or minus 0.0005 meters. Now note, the fact that these have worked out to be the same is pure coincidence. So our volume upper equals 0.1255 meters, and our volume lower is 0.1245 meters. Okay? But now we're going to plug these back into our equations for density and work out our upper and lower bounds. Okay? Oh, and if you were wondering why I've left it as 0.0125 kilometers rather than kilograms, rather than timing it to grams, it's because my density was in kilograms per meters cubed. So I needed to keep this in kilograms and this in meters cubed. So, density upper equals 0.1255 over 0.1245, and that equals 1.008032. So the upper, I'm going to round to 3 significant figures, 1.01 kilogram per meter cubed. The lower is 0.1245 over 0.1255, and that equals 0.992032. So D lower equals 0.3 significant figures again. That was not a significant figure. 992 kilograms per meters cubed. And there we go. That is our upper and lower bounds for density.